Let's have a look at this figure, which can help you to understand these basic steps which I explained you as the algorithm for a basic k-means clustering. So initially, we have a random sample or scatter plot of different data points, and we basically choose an arbitrary number for the value of k. So here we have selected k is equals to 2, which means that we want to have a total of 2 clusters out of these data points, and this value k has been selected as an initial cluster center. Now what we need to do is we need to assign each object to most similar cluster center. So after having a cluster center, we will basically calculate the distance between each data point and the cluster center, and on the basis of those distance we will form the groups. Now once we have the initial or basic groups, then we will update our centroid, or which we also are saying as a cluster center, and we will basically have an updated cluster center. Then on the basis of that updated cluster center, we will reassign our instances or data samples to those clusters. And once we have reassigned, then we will repeat the same step again, and we will update our cluster center. Once we have the updated cluster center, then we will reassign those data points again depending upon that updated cluster center, and that reassignment of course will be basically based on the distance measure which we are calculating between our data sample and the centroid or the cluster center, and we will repeat these steps until we reach to a convergence point. An algorithm for partitioning or clustering n data points into k disjoint subsets as j containing data points so as to minimize the sum of squared errors. Right? So our target is to minimize the sum of squared criteria. So we can say that if we have an n number of samples, right, then our target is basically to minimize the squared sum of this distance. Here xn is the vector which is basically representing the number of data points, where n is the nth data point, and this mu j is basically the centroid or the cluster center which we are calculating and updating in each iteration, right? And this cluster center is basically belongs to the subset Sj. So if you look into this animation, you will see that when we try to execute this basically shows that these cluster centers will tend to move towards the mean of both these clusters, and with every iteration they basically update themselves with the updated value. So if I execute this, you will see that these cluster centers are basically moving towards the mean after every iteration of the algorithm. So let's have a look at a numerical example in order to further understand the basic concept of the k-means clustering algorithm. So what you need to do is you need to keep in mind the basic steps of the k-means algorithm which we have discussed, and also keep in mind the flowchart of the k-means algorithm. And on the basis of those same algorithmic steps, we will basically doing clustering of this data set. So consider a data set in which we have a total of 6 samples. We have total of 6 samples here. This is our sample number 1, which have an x value of 185 and a y value of 72. So each sample of our data set have an x value and a y value, and all these x and y values are arranged in a tabular format like here. Now on this data set, we basically want to apply a k-means clustering algorithm so that we can make groups of these different samples. So remember, what was our first step is to have an initial value of k. So let's we initialize the value of k with 2, right? So we can basically for the time being just keep in mind that we are having this value as a random guess, but there are ways and methods through which we can have an optimal value of k at the beginning, and I will tell you all these methods at the end of our lecture. But for the time being, just keep in mind that we are having this value of k as a random value, and we are initializing it as 2 for this specific example. So if we have a value of the value of k as 2 here, it means we will be forming two different clusters, and we can say that our first cluster will be k1 and the second cluster will be k2. And let's have the cluster centers, and for the simplicity and for the sake of this example, we are treating our first cluster as the centroid, right? So we have two initial centroids, in which one is k1 and the other is k2. The value of k1 is 185 and 72, and for k2 we have 170 and 56. Now once we have the cluster centers and the total number of clusters, the next thing is that we need to calculate the distance, and we are using Euclidean distance here. So we need to calculate the Euclidean distance of the data point and the cluster center, right? So we can use this formula, in which we have a cluster center and a data point, and we are basically calculating the distance of the cluster center and the data point. So if we already know that we have our initial centroid as 185, 72, and for one cluster, and for another cluster we have 170 and 56. Now we will be using these cluster centers or centroids in the Euclidean distance, and we will be calculating their distance with the data samples. Now what we are doing is we are using this Euclidean distance, and we are calculating the distances here. So for the cluster number 1, we will first calculate the distance between the data sample and the cluster number 1. So here we are treating cluster 1 as a data sample itself as well. So it means that we are calculating the distance of a point to itself. So that's why we are having this Euclidean distance as 0 here, right? Because every data sample will have a 0 distance with itself. Now we need to calculate the distance with the cluster number 2, right? So we can have 170, 185 here. So 170 is coming from here, 185 from here, and we have 56 and 72. 56 is coming from here and 72 from here, and we are basically computing the distance, and we will see that this distance will come out to be 21.93 in this case. Okay, so once we have the distance between the first data point and the distance with the cluster center, and then we also have the distance between the second data point and the distance to the second data point. So here we are basically calculating the distance of the second data point, which is the cluster number 2. So if we calculate the distance of cluster number 2 with itself, it will turn out to be 0. But when we will calculate the distance of cluster number 2 with 1 by using the same values, we will see that it will turn out to be 21.93. So now we have basically the distances of the two cluster centers. Okay, so once we have the cluster centers and we have their distance measures, the third point is to assign the data points with their nearest cluster centers. So in this case, we have two clusters k1, k2, and we see that one value x comes out to be 0, and the other one is the 21.93. So we will see that where is the nearest cluster center. So since it belongs to 1, therefore we will have our assignments like this. We will assign this one to one cluster and this one to other cluster. So basically there is no major change in the assignments of the cluster. So now let's look to the other data point. So if now what we are doing is we are basically calculating we are taking the data point 168 and 60. So if we go back to our table, we will see that now we have already dealt with these two data points. Now I am at this position. Now I will calculate the distance of this point, which is 168 and 60, to both of the cluster centers. So first I will calculate the distance of this data point to K1, and then I will use this data point again to calculate the distance with K2, and then I will see that which distance is the minimum. So if it's minimum to 1, then I will assign this data point to 1, otherwise I will assign this data point to